Let's wrap up the lecture. A differential equation is not just a formula, and the right-hand side of a differential equation is a continuously differentiable function defined on an open subset of the plane, and any solution is defined on an open interval. It is important that each solution is defined on a single interval. Then the Picard-Lindelöf theorem it tells us that there is always a unique solution of every initial value problem, but the interval on which the solution is defined, it could be smaller than the interval where the right-hand side of the differential equation is defined. So note that it is important that the right-hand side is continuously differentiable function, because if it is not a continuously differentiable function in a neighborhood of the initial point, then the Picard-Lindelöf theorem may not work. So that's for a general ODE. But for a linear differential equation, the theorem is actually stronger. So not only we have existence and uniqueness of solutions, but also the interval, the domain of the solution is actually the same as the domain of the right-hand side. And then we did not prove the Picard-Lindelöf theorem in this lecture, but you are going to prove it yourselves in tutorial as a series of exercises. Okay? And the condition of continuous differentiability will become clear, and what you are going to see is that the actual condition in the Picard-Lindelöf theorem is a bit weaker than continuous differentiability, and the reason I require continuous differentiability here in the lecture is just that it's easier to verify and that it's easier to memorize.